Moon Base Development. NASA will establish the moon base in the lunar South Pole region through a phased, iterative approach that builds capability over time. By starting with near-term technology demonstrations, robotic missions, and early experiments, NASA and its partners can test systems, learn quickly, and steadily mature the capabilities required for continuous human presence on the moon. NASA will begin with a rapid series of robotic missions to scout the lunar South Pole region, test technologies, and prepare for surface operations. Scroll below to learn more about some of the key missions, assets, and technology demonstrations planned for Phase 1 of moon base development. By 2029, NASA will transition to assembling semi-permanent infrastructure and initiating early habitation and logistics operations. Scroll below to learn more about some of the key assets, demonstrations, and activities planned for Phase 2 of moon base development. This phase will scale operations to achieve a sustained presence, with routine crew rotations and continuous surface activity. This is when living and working on the moon becomes a reality. Scroll below to learn more about some of the key demonstrations and activities planned for Phase 3 of moon base development. Phase 3 of moon base development will include semi-permanent habitation modules with more spacious interior for crew living and operations. Operational fission surface power systems capable of delivering steady, reliable energy through the long lunar nights, leveraging in situ resource manufacturing. Pressurized rovers enabling long-distance travel, exploration, and science operations. Advanced logistics networks supported by crewed and autonomous rovers to keep the base supplied and functioning year-round. Delivery of up to 38 tons of cargo annually to sustain habitats, power systems, logistics operations, and major science outposts, enabled by low-cost reusable heavy lift capabilities. During Phase 3 of moon base development, NASA plans to expand lunar surface habitation capabilities from the initial short-duration systems demonstrated during Phase 2 toward more advanced infrastructure designed to support longer-duration human presence. Building on earlier habitation efforts, Phase 3 systems are expected to incorporate larger habitation modules, along with expanded environmental control, power, and life support capabilities. Planned habitation infrastructure may also include airlocks and module aggregation nodes designed to support interconnected habitats. During Phase 3 of moon base development, NASA plans to advance from early in situ resource utilization (ISRU) demonstrations toward more sustained implementation of technologies designed to use lunar materials for exploration and surface operations. Building on ISRU testing conducted during Phases 1 and 2, Phase 3 efforts are expected to focus on utilizing lunar resources in commodities that could help reduce launch mass, operational costs, and risks associated with long-duration lunar exploration. ISRU demonstrations could include extracting oxygen, water, and hydrogen from lunar regolith while also exploring techniques for converting regolith into durable construction and infrastructure materials through approaches such as sintering, corbelling, and 3D printing.